Okay, good afternoon, everybody. This is going to be a 15-minute talk about fraud detection with a focus on time. So to focus on time, I'm going to kick off a little bit of a demo in the background, and hopefully we'll return to this and it'll be nicely working. I'm asking Kubernetes to do some things. So, fraud detection and machine learning. So a little bit about machine learning. If this is connected car, then a connected car is somewhere out in the wilderness. It sends a signal to a base station and says, what do traffic lights look at? Human being says, oh, this is what traffic lights look like. Sends it back to the car. Well, that's too late, because a late answer is no use. But this, in machine learning, is one of the ways you train models. You pop up pictures and you give it guidance for what the correct answer is. So fraud detection. Credit card fraud. Why does time matter more than money? For those of you who can see, I have in my hand a real credit card, mine. And if I was wanting to pay with something, I would do a tap and pay, perhaps. So the little icon is, here's the credit card in your hand. You do a little tap. Your transaction detail goes up to some business processing unit, which in this case I'm saying is Hazelcast. You have to run some assessments on that transaction. Is that transaction going to be allowed? Am I doing something in a strange location at a strange time of day with a strange vendor? And I come back with a fraud score. That fraud score is a percentage. How suspicious is this transaction? The important part is this happens in the blink of an eye. You've got maybe 150 milliseconds to authenticate, authorize, approve that transaction. It's what we call the eye blink. It takes 150 milliseconds to blink your eye. We can try it. If you're slow at processing, you don't get the answer back in time. You haven't worked out, is this transaction fraudulent, before you have to accept it. So you've accepted the transaction, it's fraudulent, you've lost money. Not good. So, some quick numbers on fraud. I got this off the website, there's a link here. That's how many transactions. 500 million transactions a day. 70 million US dollars in fraud a day. I'm from the UK. So these are some figures for 2008 and 2018. You can see that the amount of fraud is being reduced by cleverer processing. But the important thing, and I put it on the right, just a little topical reference, different on one side from the other now. But how do we make this improvement? Because we can't change that 150 milliseconds. So how can we make fraud better? The way we've got to do it is to make it faster. If we can detect faster in the same time window, we can run more validation rules. So that's what it's about, time. We can run it faster. So how? Scaling. Here's how. Scaling for fraud transactions is quite simple. There's multiple transactions here. There's transactions down the left. 4 different people are tapping their cards at various places. Card 1 for $5, card 2 for $4, and so on. We can stripe that across rules engines, because the validation of card 1 has got nothing to do with the validation of card 2. And all we might do is take the credit card number and modulus it by the number of processors. So card 1 and 3 go to processing unit 1, cards 2 and 4 to processing unit 2, and they just do the same processing. Because your card, your transaction's not the same as my card. But if I do 2 transactions with my card, it goes to the same processing unit. So that's how I'll spot things like my card's used twice in a row, a double tap. So 4 transactions, 2 processors, each processor's dealing with 2 each. If we get higher volume because something's happening like Black Friday, all we want to do, add another processing unit. And then you restripe your transaction. Again, the transactions for a particular card are going to the same processor. Now, transactions for other cards are going to different places. So it's routing is what gives you the scalability. you can just add another process, all transactions for the same card going to the same place. So you'll spot repeated transactions for a card. So that's good. Resilience is next. 5 nines uptime, that's what people want. That means 6 minutes downtime in a year. Actually 5 and a bit minutes, but I've just gone for 6 for simplicity. If you remember back to those numbers, that means 200,000 transactions passing through in 6 minutes. On average, $30,000 of fraud undetected in 6 minutes. And as soon as you sell business user, we want 5 nines availability. They're going to say we want 6 nines availability, 9 nines availability. This problem's only going to get harder. And pragmatically, everything I've ever seen fails at the busiest time. So if we can scale by adding more processes, then we also don't care if one crashes. So that's how you get that resilience, because all you're doing is remapping the existing transactions across the available processes. Now, there's obviously going to be a little bit of a speed bump when you try to send it to somewhere that's gone off the air. So you will, it's not absolute magic, but you can keep running. If you've got multiple, you can cope with losing some. So the next part is deployment. In the old days, you used to switch things off and switch it on to pick up new software. Well, that isn't going to cut it, not with 5 nines deployment. So we want a way to move code to running processes. And that's just serialization if you're a Java person. So what you would do in machine learning terms, you've taken your model, you're something that you've trained offline, perhaps with human assistance. You would send it to your operations department or DevOps if you're DevOps yourself. And you send your model to your processing engine. You just serialize it, send it across the network. And that creates a new rule to process. Right, let me do that live while we're running. I've got my commands. Let me check. Everything is started up okay. I'm running 2 Hazelcast instances. So now I'm going to submit a processing job, and we'll come back to this in a second. So the second part of deployment is correctness. What happens when we want to improve our processing? Well, what we do is we add a new rule alongside the old rule. So we're running 2 versions of Rule 3. Now that slows things down a little because you've now got to do more processing, but you can compare the output of Rule 3 while Rule 2, both versions of Rule 3. Which one is an actual improvement? Because you're running both. You don't take one away and then add one in. You add one in and then take one away. So you run 2 at once, and you find out which one is better. So all good news? No. There is some gotchas you've got to be aware of with scaling. So there's stuff you can do. You can deploy code live, which is what I'm doing in the background. You can maybe hear my laptop heating up. But imagine we're now looking at extra information on your transaction, the merchant, the person that's selling. So we have transaction card number 1, $5. Let's now enrich it. That transaction's going to merchant number 1. If you look down the left, you'll see that of that 5 transactions, 4 are for merchant number 1. But if you look at the way they're striped across the available processes, most of them's got 2 transactions, so you're not necessarily going to spot 4 items going to spread across. So if your routing is by card number, you might not spot by merchant. You have to start doing multiple rules across multiple ways of slicing your data. So back to my demo. Let's see how it's working. So So my job has been completed and executed. So what that means is I've sent a Python script to run on Kubernetes in a Docker image. And Is it there? What have I done wrong? There we go. So what we can see down the right-hand side, resize, is I'm running through about 15,000 transactions per second on my machine because I'm running 2 Kubernetes pods, 2 JVMs running in containers on my laptop. My laptop has sufficient CPUs for that. So in fact, what I'll do now is I'll scale up. So if I look at my Hazelcast instance, I'm running 2. I say to Kubernetes, I really want 3. And it's now running 2 out of 3. You'll say it wants 3. It's going to go and spin up another machine. So that will be another pod which will join with the existing ones. That processing job will then be replicated out onto the third. And now we should have 50% more processing power in a minute or two. Let me see. So is it ready? There we go, down the right-hand side, processing rates increased to 22,500. So 50% increase just by asking for more resources, as long as you've got more resources. So we're almost done. So a little bit of a summary. Really what matters is uptime, because if you're off the air, you're losing money. Once you're running, what you want to cope with is surges. You get something like Black Friday, Cyber Monday, the Wednesday, whatever it is in your country, that's rarely a surprise. If it's is a surprise, you can just get automatic scaling. So you just add some more instances, get your container platform to respond to CPU count and say, give me more when I need more. You want to do blue-green deployments. You never want to take something away. You want to put something in first. But when you put something in, you're giving it extra load, so try and do that at a quiet time until you're sure which one is the better of the two to take out. And if you can run more checks in the same amount of time, then you find more fraud, you lose less money. Money saved is the same as money earned. And a last little takeaway, get a card blocker. So if you're walking around and somebody's got a contactless machine, walks past you, probably they've got their contactless machine not to beep. Okay, any questions? If anybody wants to see that demo again, I can demonstrate it live. We're here for the next hour or so, but it'll be downstairs at our booth. Simple takeaway is push a job to a running place, scale up and down as you need. Done?